Kia ora, here's question 1E from today's complex numbers exam. So I thought this question was probably the easiest of what I think the 3 excellence questions were in the paper. This is one where we're given 2 complex numbers, u and v. U is 3 plus I and v is 1 plus 2i. And we have to figure out what the possible value or values of the real constant k are if the magnitude of u over v plus that constant is equal to the square root of k plus 2. So pretty clear what the strategy is here. We're just going to substitute in and go. But I'm going to do the work on u and v before I start putting in the magnitude stuff. So let's just work out, first of all, what's u over v? Well, u over v is 3 plus I over 1 plus 2i. We're going to times by the conjugate over the conjugate. And at this stage in the year, hopefully you're pretty confident with looking at that denominator first and seeing that that's 1 plus 5, and in the numerator we get 3 plus I minus 6i plus 2, right, coming from these two multiplied together. You should be feeling pretty good about that because you can see that you've got these nice numbers here, except that of course I've made a mistake. 2 times 2 is not 5, 2 times 2 is 4, right, there we go. And that gives me 1 minus I. So u over v plus k is going to equal 1 minus I plus k. And going back to the question, we have to solve this now. Right, so the magnitude of u over v plus k is going to be the magnitude of grouping the real and the imaginary bits. We've got 1 plus k minus I. And the definition of the magnitude means I've got 1 plus k squared plus 1 squared. And we can simplify that further to get k squared plus 2k plus 1 plus 1, which gives me this. But we were told at the outset that that has to equal k plus 2. Sorry, the square root of k plus 2. All right, squaring both sides, we get k squared plus 2k plus 2 is equal to k plus 2. Now we know that whenever we do anything with squares or square roots, we have to be careful to go back and check the solutions. So I'm going to do that at the end here. Solving that gives me k squared plus k is equal to 0, which is very nice and easy. So I get k into k plus 1 is equal to 0. So 2 plausible solutions, k is equal to 0 or k is equal to -1. So now we have to check each one. Let's first of all do k equals 0. Then we have u over v plus k is just equal to 1 minus I. And we know the magnitude of 1 minus I is equal to root 2, which is equal to the magnitude of 0 plus 2. Right? Remember that the right-hand side of that equation was this. So k equals 0 is a solution. Now we're going to do the same thing for k is equal to -1. So now we get u over v minus plus k is equal to 1 minus I, take away 1, which is -I. And the magnitude of -I, we're sitting down here, is equal to 1. Looking at the right-hand side, the square root of k plus 2 is equal to the square root of -1 plus 2, which is the square root of 1, which is 1, which means that k equals -1 is also a solution. So there you go. I think that is quite, it's a little bit different from what we've seen. I think it's pretty straightforward with what you should do in that question, so hopefully that one has gone well for you. I will do 3E after I've had some dinner to fortify myself before I do a whole lot of quite messy and not particularly insightful algebra back later on.